Hello everybody, welcome to our second practical session. So what was the agenda for this session? It was use of for loop, Pascals triangle, nested if, switch, break and continue statements. Just to recall, in my first practical session I already covered different types of data type which is used along with the size they take. Next I also discussed about the nested if else, or rather the simple if else, and the while do and do while. So here we will be doing the use of for loop, Pascals triangle, nested if, switch, break and continue statements, and some other operators, so which I will show you. But see, actually what happened that in this kind of videos, when I code everything in this session, then it becomes boring and it takes a lot of time. So I decided to code few things beforehand so that you can understand them and we can focus more time on the explanation. So let's proceed. Our first thing which is to be covered is use of the for loop. So I am already there in the terminal. So let's check that what are the directories under the home directory. We should move to the tutorial directory. Then again type ls to check that what is there. There are two files. One is C and another one is today_agenda. So we should move to the directory C. And again type ls. So I have already created a folder for you, that is PracticalSession2. Let's move into that folder. cd PracticalSession2. So now I am within this PracticalSession2, and to demonstrate the for, okay, let me check again that what was the agenda. Yes, so use of for loop was the first session which I was expected to cover. So here you can see numerous number of .c files and .exe files. So this program have already been written and they have been compiled, but still I will open the for.c file. Nano for.c. So this is a program which demonstrates the for loop. As you can see that it is following a very conventional method of writing a C program like hash include stdio.age void main. Then I have declared two variables I and terms. Now first what is happening, that the user is typing something like how many times, and that number of terms, okay, I have declared that variable to store that how many times the user is going to print the string. So that variable which is of type integer and is terms and is declared as terms. So that value when the user enters, it will be scanned from the keyboard and placed into memory using the statement scan it %d and %terms. Now here comes the role of I. I told you something called the intermediate variable during my theory classes. So here we will see that how I works as a intermediate variable. Because the user has entered a certain number of terms, now I will traverse from 1 to total number of terms. In other words, if user have entered the number of terms as 10, so I will start from 1 and traverse through all the numbers between 1 and 10. That is why we have initiated the intermediate variable as 1, and we will continue I, that means I will be traversing the whole set of values of terms. So it will start with 1 and it will end with the number which user has input as how many times. So since the user has entered say 10 times, so iteration will start at I equal to 1 and it will continue till I equal to 10, and in each term I will be incremented. That means the value of I initially it is 1, and for I equal to 1 Asphodel education point will be printed once. Likewise for I equal to 2 it will be printed 2 times, and in the similar fashion when I is equal to 10 then it will be printed 10 times. So that's it. So we will be getting output 10 times when the user entered the number of times as 10. The main thing here in the for loop is you can understand that the loop is starting at I equal to 1. That means it must have a starting point. Then it will traverse through the whole set of values. That is why I have given the thing as I less than equal to terms, and I plus plus, that means I is incrementing at each step. So let's check the output of this program. Control O, Control X. Let's clear this. Okay, so let me compile. Just again make an NS to be sure that what is the name of the file. It is for.c. So we will just type the command for compiling this for.c. We will write gcc for.c minus o. Suppose the name of the executable file, and the object file is for. So I have written it as for. Press enter. So there is no error. Now we will just run the program as /for. Okay. Now as per the program you have to enter that how many times you want the to print the string. Suppose I want to print it 5 times. So now I have entering it as 5. Let's see. Yes, it is being printed 5 times because I have started from 1 and the number of terms is that the number of times I want to print it is 5. So for I equal to 1, I less than equal to 5, I plus plus, printf Asphodel education point, that will be the program. Okay, and so I has traversed from the value between 1 and 5 and we have got our output 5 times. Again check another time. This time I want to print it say 10 times. So now I will traverse from 1 to number of times, that is 10. And each case I is incremented, otherwise the program will never terminate because I have initiated to 1. So if I don't give I plus plus, then that value will never get incremented to 10. So that is all about the for loop. I will open the program again. If you take note, then you can take it. So let's type nano for.c. okay, so that is it. This program demonstrates the for loop. Okay, then I think you have noted it carefully. Now let's look into our next agenda. Okay, so this use of for loop, this particular portion I think we have already done. Let's mark it. Now the Pascal triangle. The Pascal triangle is a very interesting problem. Okay, you must have encountered by through those kind of shapes. Okay, what a Pascal triangle is. Now this Pascal triangle has a very important utility in C program demonstration because it can show you that how nested for loops work. Okay, how nested for loops work. Suppose I want to print something like this. Let's proceed in this document. Suppose I want to print something like this: 1 1 2 1 2 3. Okay, 1 2 3 4. Let me another row: 1 2 3 4. Okay. So this is a Pascal triangle. Okay, I want to print. Let me make it a bit larger font size. So let's make it as 14. Now the output which I am expecting, you can see it very clearly. So this is the output say which I want. Okay, now if you note very carefully that this pattern is repeated. First I am getting 1, then I am getting 1, 2, then I am getting 1, 2, 3, then I am getting 1, 2, 3, 4. In the next line, I am getting 1, 2, 3, 4, 5. Now, how to print this kind of structures? Okay, how to print this kind of structures? Now, to print this kind of structure, we need the nested for loop, because we need two intermediate variables. Note carefully, we need two intermediate variables. What are the work of those two intermediate variables? Suppose the two intermediate variables are I and j. Now, what is the purpose of this? See, one of the variable will control the number of rows. Here you can see the number of rows are 1, 2, 3, 4, 5. And can you see the similarity that the fifth row is having the numbers as 1, 2, 3, 4, 5. In the fourth row is having the numbers as 1, 2, 3, 4. The third row is having the numbers as 1, 2, 3. The first row is having only 1, whereas the second row is having 1 and 2. That means there is a pattern, and I is nothing but determining how many rows will be printed, and j will be determining that what values will be printed in each row. Note this point carefully, that I is determining how many rows like this or following this pattern will be printed in the terminal, and j will be determining that what values in each row will be printed. So let's move into that program to see how it is working. Again, make a clear statement here and type ls. Okay, so open the program as nano pascal.c. Now note this program carefully. As I told you that we have taken rows as a variable, ROW is rows as a variable, I is an intermediate variable, and j is another intermediate variable. Now first I am asking the user that how many rows they want. Then I am scanning that value into the memory through scanf %d ampersand rows, as number of rows is stored in the variable rows. So next, what is happening in the first part of the for, that I have already commented it out. For I equal to 1, I less than equal to rows I plus plus. That means I will determine the number of rows. Now, number of rows cannot be 0. So I must be initiated to 1, and then user has given a certain number of rows. So I will continue until the number of rows is reached. So I must be less than equal to rows, and each time to go into the next row we must type I plus plus. So I think the first for is very much clear, and I have also commented out, you can note it, that I determines the number of rows. It is very clear that I is initiating from 1. Why from 1? Because number of rows cannot be 0, and I will is the intermediate variable, will traverse through all the rows. So it has the terminal point as the total number of rows which the user may have entered, and I must be incremented at each step, otherwise the total number of rows, I cannot traverse to the next row. Okay, otherwise whatever I want to get printed in the subsequent row, I can't do that unless and until I increment I. Now come to the next for. The next for determines what values will be printed in each rows. It determines what values it will be printed in each rows. Now what is printed in each rows is governed by the value of I, is not it? It is governed by the value of I. Now look back into the Pascal triangle, that 1 is printed because the number of rows is 1. 1 and 2 is being printed because this is for the second row. 1, 2 and 3 is printed because it is for the third row. That means we can, by following this pattern, we are assured that the values being printed are exactly dependent on the rows. If the number of rows is 5, then we are printing 1, 2, 3, 4, 5. So that values must start with 1 and must end with the number of i's. suppose our number of rows is 2, then what will be printed? First 1 will be printed for the first row, and for row number 2, 1 and 2 will be printed. Why this? Because the number of rows is directly dependent on what value will be printed. So it is very much clear, I think. So j equal to 1, j less than equal to I, j plus plus. That should be the second for loop for printing the values in each row. J stands for 1 because you can see the given Pascal triangle, nothing is printed at 0, and also number of rows is not 0 at any point of time. So j must start with 1. J less than equal to I. That means if number of rows is equal to 1, then only 1 will be printed. If number of rows is equal to 2, then 1 as well as 1 and 2 will be printed. Similarly, whatever value is assigned to I, that must determine that what value will be printed by j. And ultimately what I need to get printed? I want to print the j only, because I don't need I. I need the values of j, because number of rows is determined by I, but values in number of rows will be determined by j. So that is why the printf statement will only include j. And after the first for loop is over, see, I have put one printf/n, because otherwise all the rows will be mixed up. There will no separate row will not get generated. So to generate a new line so that the second row can be printed, within the outer for loop I have printed a blank. I have printed a blank to mark the new line. Okay, I think the program must be clear to you. Still you have questions, then you can always put a question in your comment section. Now see that what happens if I compile this program. Save this, type Ctrl X. Now let's compile this. GCC Pascal.c -o Pascal. We have successfully compiled it. Now let's run this. Okay, I put a comma, so it should be dot, remember. Okay, enter the number of rows. Now I will determine, I will just treat the number of rows as, I will enter it as 10. So what is the expected output? It should be 1, 1, 2, 1, 2, 3. Likewise, the last row should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's check. Okay. Now the /n in the outer for loop determines the new line so that the rows are not mixed up. They are always printed, the output is always printed in the form of rows, that is in the next line. And here the new line is nothing but a new row. The new line is nothing but a new row. Okay. So I think this thing is clear. Now you can modify the code Pascal.c in many different ways, okay, to get different kind of patterns to be printed. Now the number of rows and the values printed in rows must be connected in some way. You have to find that connection. You have to find the relation between the number of rows and the values to be printed within that rows. If you can bring a relation between them, that is, say the number of rows is governed by the intermediate variable I and the values to be printed in each row is governed by the variable j. Then if you can bring up some relation between I and j and put them in a nested for, then the desired output can be obtained. Okay. I think this will be a very interesting task for you to modify the different values of I and j to bring up different patterns as expected in the question. Okay. If the main purpose of this Pascal triangle is to demonstrate that how the nested for loop works in this context, I mean to say, and also you can make your own patterns, but the trick is you have to find some relation between the rows and the values to be printed in the rows. You have to bring up, you have to come up with the relation. Okay, now programming is something where you cannot be it is like mathematics, means all kinds of programs cannot be done, okay, in the class or in some session or in some online class. So the trick must be learned, and that trick should be applied in many different ways. And here in Pascal's triangle, the trick is to plot a relation between the number of rows and the values to be printed within the rows. Fine. So let's come to our third assignment. Our third assignment is nested if. So this one is very easy, and while learning nested if, you can see other interesting parts. Okay, I am using this WPS Office, and so not everything is working as expected. Leave it as it is, not an issue. So let's move into the nested if part. Okay, now let's open the nano nested if.c program. This is very simple. You can check it by yourself that I am entering a number. Okay, I am taking one value from the user as number, and the other value I have declared that variable with a fixed value, that is int k equal to 6. Okay, here you can see the use of the comma operator also. Okay, if you follow my theory lectures very carefully, then you can understand that this is the application where I have used the comma operator, because I have declared two variables. One is int num comma k equal to 6. So here I have declared one variable, okay, as num, which the user will be inputting, and the other variable k, whose value I have fixed before. Okay, that value is 6. Now what happens? If the user enters something which is less than 5, then only the if within the if will be executed. That is, if number less than 5, this condition is true, then only the second if clause will be executed. That is, if k equal to 6. Now otherwise, if user puts something which is not less than 5, then there is no question of executing the nested if, is not it? So we will check this. Now the bottom line is that if the first if is true, then only the second if will be executed. Now as per this program, the second if is always true, because I have declared k is equal to 6, and my nested if, that is the if within my if, is always true, because I am giving the condition as if k equal to 6. So whether the printf statement will be executed or not, that is solely dependent on the outer if, that is if number less than equal to 5. So the bottom line is that if number less than 5 this is true, then printf statement will be executed. If number entered by the user is not less than 5, okay, then there is no question of the second if to be executed, and consequently the value within the printf, or the set of characters within the printf, will not get printed also. Let's check the condition once more. It is number less than 5, remember. So obviously we want to set Control O, we will enter. Okay, so let's compile this. GCC nested if. I think you were getting interest. If you want me to modify the mode of teaching in some different ways, then you can tell me. I will try my level best to teach as per your need. Anyways, so I have compiled this nested if. Now let me run the nested if program. Remember, just recall, because you have just saw that what is written in the condition part of this nested if.c file. Enter the value of number. The condition was number must be less than 5. So I am entering something which is more than 5 and see that whether our output is printed. No, see, I have entered the value more than 5. I have entered it as 10. So our printf part is not getting executed. Now we will again run this program with a different value of num. Now we will enter something which is less than 5. We have entered it as 3. Now our output is coming because our condition in the outer if was if number less than 5. And the second if was always true because I initiated it to 6 and I was checking the condition is as if k equal to 6. Okay, I think it is very easy, but the point is that another important observation can be made from this program. What is this observation? Now let me comment this nested if part in this program. Let me comment this part. Okay, this part is commented, and here you can see I commented something before. Let me remove that comment. Let me remove that comment. Now here is the important thing to note. See that a nested if is similar to some AND condition, is not it? If you see that if number less than 5 and if k is equal to 6, if both the if conditions are true, then only the output will be printed. So can't this be clubbed into one if statement? Yes, it can, because we have the logical AND operator. Recall my theory classes, okay, otherwise you will not be able to understand. I already covered all these things in my lecture 4, I think. I can't recall, I think it is in lecture 4. I have covered a detailed session on operator. Okay, there I explained you about the logical operators, and here is the use of logical operator. If number less than 5 and k equal to 5. Okay, k is not 5, k must be 6 because I initiated it to 6. So now to make these both conditions useful, I am writing if number less than 5 and k equal to 6. That means these both conditions are true, then only the output will be printed. If any one of the conditions is false, then the output will not get printed. So let's check. We will first input a number which is less than 5, then we will put something which is not less than 5. Let's remember to compile each time, because whenever you make any changes in the file, then the compiler will not understand it unless you compile. And if you run without compilation, directly the executed file, then there is a chance that the old thing will again come. So remember that if you make any change, then compilation is the intermediate step. So again I need to compile because I changed the program. Okay, now let me run this. Now enter the number. Now the condition to make, I will make both the conditions true so that the printf is executed. So the value of number I have put it as 3. See, now the output is coming because both of my conditions are true. Now make one condition as false. Either I enter, let me enter a value which is more than 5. Let me enter it at 6. Is the value printed? No, the value is not getting printed. Similarly, you can also modify the k value. You can enter the value of number as 3 and k value is modified to something else because k was initiated to 5 in the program. But if you change the value of k here, okay, then also your program won't print asphodel, because again the k value is modified and the second part of the logical AND condition is not true. So in that case also it will not get printed. The main point is that both the conditions under check must be true to get that printf statement executed. Now again let's recall the logical OR operator. The same program, if I replace the logical AND operator with the logical OR operator. Now see that since k equal to 6 is always true, so asphodel will get printed irrespective of the values being entered by the user, because in OR condition, if one condition is true, then the output is always true. So let's check. Still we need to check it, because there is nothing called theory in computer science. You have to prove it. Okay, enter the value of number. Begin. Let us give some number which is not less than 5. But see, the value is getting printed because your k value, which is set to 6, okay, and our OR condition is also having the value of k as 6. So irrespective of whatever the value of number the user inputs, the printf statement within the if will always get printed. I think these things are very clear to you. Okay. Now you can also check the NOT condition in this way. We can check the NOT condition. If, let me comment this first. Let me comment this first and write something fresh for the NOT condition. I am just commenting this and I will write something for the NOT condition. If not k equal to 6, then you printf. Okay. Now tell me why this can't be executed, because k is 6, but if I enter 6, okay, then only the value will be not printed. Otherwise in all cases the value will get printed. Okay, if not k equal to 6, you have to print asphodel. Now if I enter the value as 6, because otherwise enter the value of number. Okay, now let's put it as number because user is entering number. So at number equal to 6, not number equal to 6, asphodel will be printed. So other than every other value of 6, every value of number other than 6, asphodel will be printed, and when user enters 6, asphodel will not get printed. So let's check. So again remember to compile it. Compiled it. Now we will be running it. So if the value is something other than 6, okay, then the value is not getting printed. Fine. So let's check once again. That if not number equal to 6, then the value will be printed. Okay, and if the value is equal to number entered is equal to 6, then the value will not get printed. Okay, so whatever the user is being entering, that is dependent on whether the value will be printed or not. Okay, so you can also execute the not condition like this also. Number not equal to 6. If number not equal to 6, then asphodel will be printed. If number equal to 6, then number will not get printed. Okay, so let's check. We will just compile it and we will try to run it. Enter the value of number. So when the number is not equal to 6, then it will be printed. Now let's print it as 6. It is not getting printed. Now we should put something other than 6 and it should get printed, unless we are. Yes. So it is okay. So when we are entering 6, it is not getting printed. Something other than 6, it is getting printed. So I think it is clear to you. So the nested if along with certain operators we have covered. Still two things are remaining. One is the switch and another is the break and continue statement. Most of the things I am covering, so you should not face any problem. Again, ls, we will move into the switch.c program now. So let's move to switch.c by nano switch.c. Now see this program, okay, it is taking two library functions. One is stdio.h, another one is standard library.h. Now standard library.h has nothing to do except this particular line here to exit. Okay, to exit from the program, that is exit 1. That function is defined exit 1. That means exit if true, that is if the true condition is given by 1 here, the exit 1, that is the exit function is taking 1, that is the true. It is always boolean, it will take boolean argument. Now exit function is already defined in the stdlib header file, so I have to declare the standard library header file, otherwise that exit functions I cannot call it from my program. Again, recall my theoretical classes that library functions I can only call directly from the main when my appropriate header file is declared. So exit function, to call this from main, I need to declare the appropriate header file, which is standard library, that is stdlib.h, and I have included it in my program. So now move to the program actually. Okay, within the main I have declared many variables here: a, b, choice, sum, diff and product. Now recall the switch statement again. Remember that unless and until you follow my theory classes, these things you can't understand. So if you have any doubt, you can always go back to my class on control structures in C, which was probably lecture number 5. The control structure in C, first study that, okay, first follow that lecture, then come back to the practical class, otherwise it will be difficult for you. Okay, it will be difficult for you. I will try to put the link of those lectures in the description of this video for your reference. But remember, you cannot learn programming like this, that suddenly you are jumping to lecture 7 without following the other 6 lectures. It will be difficult for you. It is not impossible, but it is very, very difficult. So come in sequence. If you have any doubt, okay, then you move back to the previous lectures. If you have questions, you ask us in the comment section, okay, but don't just rush through, because I am telling you repeatedly that programming needs practice. It needs thorough conception. You need to think analytically, you need to think logically, otherwise you cannot do programming. There is no question of memorization here. Okay, you have already saw that even after so many days of programming, some of the programs when I am writing, they are not working on the first instance. I myself have to look into the errors, then again debug them, change them. Okay, so it is a programmer is always, he or she should be open, he or she should follow everything, keep himself or herself updated. Okay, and there is nothing called memorization. Anyways, let's recall what was a switch condition. Okay, what is a switch statement? Not condition, it is a statement. Let's recall it. Now user will be given certain choice, okay, and it is a kind of branching operation. That means the switch will take certain parameters. Okay, suppose it will in our program, it is taking the parameter as choice, and that choice will be an input by the user. Now when the appropriate choice is encountered, the program branches to the case for that choice. Now suppose here I am taking two numbers from the user. Okay, I am inputting them as ampersand A and ampersand B. I am inputting them, I am putting them in the memory. Okay, and for this I have already declared A and B. Okay, now those two numbers are being given as input by the user, and they have been stored in the memory through the scanf function. Or now what is happening? Now I am asking the user to enter the choice. Okay, I am asking the user to enter the choice 1, 2, 3 or 4. That means the user can make 4 choices, either 1, either 2 or 3 or 4. Okay, and that choice is also recorded through scanf %d ampersand choice. Now what will the system do based on the choice of the user? So that branching comes using the switch statement, like switch choice. Now suppose the user has chosen as option as 1, so switch 1 will be appropriately branching out to case 1. Now what happens in case 1? Case 1 is doing the sum of A and B. A and B has already been entered by the user, so, and I have already declared the sum variable. So through case 1 the user can get the sum of those two numbers. Again, if the choice was 2, then user would have got the difference of those two numbers. If the choice is 3, then the product of A and B was obtained, and in case the user chose to put his choice as 4, then the system will exit and it will print thank you exiting. Now in case the user is trying to be smart, he is not doing as per the instruction being given by the programmer, like he is entering something which is neither equal to 1, 2, 3 or 4, then in that default case something funny will be printed. Okay, because the user is trying to be smarter with the programmer, and the programmer is not going to be someone who will hold back. Okay, so he will simply write wrong choice, acting smart. Okay, and will exit the program. That is all about this switch program. The main thing is that the switch is dependent on the variable choice. Whatever the choice the user has made, based on that our program will branch into the appropriate section of the code. Appropriate section of the code, and the values of A and B will be taken into perusal, and based on the operation, based on the arithmetic operation being performed within that case, okay, the output will be given back to the user. Okay, so whenever in your real life problem you need your actions to be branched based on specific choices, then you take up the switch statement. I will repeat, whenever you want your output to be branched according to the choices made by the user, okay, then you have to use the switch statement. So I think I have explained you properly. Still you have questions, you can always ask them. So let us run this program and see. Let's compile it. GCC switch.c -o switch. This will compile the file. Now the executable switch is formed, so I can always type /switch to run the program. See, I have been asked to input two numbers, 34 and 56. Now I will be asked that what I will do with the number. I choose option 1, and the program has branched to case 1, and in case 1, as you can recall, we were doing arithmetic sum operation with the variables a and b. So the addition of 34 and 56 is given as output. Let's try it again with some other choice. Let's try with 2 and 3. I have entered the choice as 2. The difference is 1. Now the program has branched to case 2, as you know. Similarly, the program will branch to cases 3 and 4. Now let me put some default value. I have given two numbers. I have given some default value, say 78. So it's wrong choice at this point. That means you are not doing whatever the programmer is asking you to do. Now it will naturally give you some star message. But you don't want to continue anymore, you want to exit, so you type 4, thank you, exiting. That's it. So this is all about the switch statement, where the program is branched as per your choice. Now the final part. Switch also we have covered. Switch also are covered, and the final part is break and continue statement. Break and continue statement is an interesting part, so we should not skip it. Let's open nano continue.c. Here the program is written. Okay, now we want to check what is the difference between break and continue. I told you during my theoretical classes that this is best described in a practical class. Now, what is the purpose of break? You see that in this program the continue is commented out. I will obviously comment the break later and remove the comment from continue, but here the continue statement is commented out and the break is there. So let's check what happens in a break. Now here look into this, that for I equal to 1, I less than equal to number I plus plus. That means I want to print certain number of numbers. The user will enter some number, okay, and based on the end number, suppose the user has entered 10, and that means for I equal to 1, I less than equal to 10, I plus plus. Okay, if I have entered up to 10, then the compiler will be checking I modulo 7 equal to 0. That means if that number is divisible by 7. Okay, I modulo 7 equal to 0 means if that number is divisible by 7. Now if that number is divisible by 7, then the program will break. That means it will come out of the loop, else it will be printing the value of I. That means this program, if I enter 10, it will print all those values between 1 and 10 until it encounters something which is divisible by 7. Okay, so this program, if run, is expected to run until 1, 2, 3, 4, 5, 6, because 7, when it encounters 7, then 7 is divisible by 7. So if conditions become true, and it will break from the loop, that is nothing other than 1 2 3 4 6 should get printed. And until 1 2 3 4 5 6 I modulo 7 equal to 0, this is false, so the else part, that is I is getting printed. Let's check this. So we have to compile this, gcc continue dot c minus o continue. Now dot slash continue. So number I am entering 20. So whatever number I entered, because I modulo 7 will be encountered at 7 only. When the loop will traverse from between I and 20, it will encounter 7 first. So whenever it encounters 7, it should break. So I should not get anything more than 1 2 3 4 5 6, and it is exactly that. I am only getting 1 2 3 4 5 6. So whenever my condition is being encountered, now if this thing is I modulo 9, then until 8 it should get printed. Let's check. So I make it 20, 25, whatever. See, so I modulo 9 is equal to 0 is encountered when the value of the number is 9, because 9 is divisible by 9, so it is breaking, and otherwise in the else condition was being executed, and 1 2 3 4 5 6 7 8 is printed. Okay, again now let's see the continue statement. Now let's comment the break. Let's comment the break and uncomment the continue. Now what will happen in continue is that only this condition which is given in the if will be skipped, and it will not break from the loop, but it will continue the loop. It will continue the loop. That means everything will be printed except the cases where I modulo 9 is equal to 0. Remember, everything will be printed except the cases where the number modulo 9 equal to 0. Now if I type number equal to 20, then everything between 1 and 20 must get printed except those values which are divisible by 9, that is except 9 and 8. That means what? It is not breaking from the loop. It is just continuing within the loop. It is just continuing within the loop, but skipping the particular condition. That is I modulo 9 equal to 0. Let's check. So I am entering 20. So I should get all the values between 1 and 20 except I think 9 and 18, because I modulo 9 equal to 0 was the condition. Just check. See, after 8 we are getting 10, 9 we are not getting. Again after 17 we are getting 19, 18 we are not getting. That is those two cases where I modulo 9 equal to 0, they are skipped, but the whole loop is not skipped. The loop is continuing, but those values, okay, whichever is given in the if condition, they have been skipped because of the continue statement. Okay, so that's it. I have covered your whole lot of things here, and now whatever I have taught you are almost in sync with the theory. So theory and practical are almost synchronized now. So if you get through all these lectures, then I think that you will find a parity between the theory and practical classes, but again you need to practice, and in case you find any doubt, okay, first you try to clarify them through my lectures, my theoretical lectures, and go through the programs whichever I have done. Try to modify them, try on your own, okay. Use Cygwin, not Turbo C, because it doesn't work well with Windows 10. So try them, try to execute them on your own. In case you find any problem, visit my lectures which I have already covered. Still your problem not solved, you can always come back and write a comment, and I will try to explain them. Anyways, it's already got very late, and it's a long lecture. I don't think that you will get bigger lectures there, because here I had to cover lot of things, okay, lot of things, because practical classes, they are not easy, they are to be done hand-on. Now you can easily understand that why the codes were being written beforehand, because if I would have written the codes, it would have taken another 2 or 3 hours, so it would have been a very rigorous session. Anyways, thanks for watching this video patiently. I hope that you have learned few new things, and you will be applying them in your day-to-day activities, your academic activities, okay, and hope that you will be supporting us in the days to come. Thank you, thanks a lot.